Hello students and welcome to this calculus video. This is going to be another example using contextual problems with derivatives and integrals. You're going to need your calculator again, so make sure you get that out and let's get started. So this problem is about a pan of biscuits, whether those are like southern biscuits or cookies like in Europe where they're biscuits. It doesn't really matter, but the temperature of the biscuits is at 100 degrees Celsius and we take it out of the oven and we know that the temperature change is going to be modeled by this derivative. So let's find the value of b prime of 3 and let's explain what this means. Alright, so the value that I got when I plugged it into the calculator is going to get negative 8.2364. So b prime of 3 equals negative 8.2364. And we do know what the temperature is here, since we know that this is T is in minutes and that our initial degree is in Celsius. So this is going to be degrees Celsius per minute. So what does this mean in the context of the problem? Well, since the derivative at 3 at time t equals 3 minutes is negative, we know that the temperature at the biscuits is decreasing at a rate of 8.2364 degrees Celsius per minute at time t equals 3 minutes. So this is the time t equals 3 minutes after being taken out of the oven. All right, so now what we're going to do is we're going to graph our derivative, the one that we're given in the prompt, and we're gonna explain how it makes sense. So first, let's see what this looks like. All right, so the graph that I got looks something like this, and it's just gonna be a sketch that I put down here. All right, but why does this make sense? Why is it below the x-axis? Well, the reason this makes sense is because this function is representing the rate, the derivative of the temperature when the biscuits are taken out of the oven. So this is showing how the temperature is changing. So look at this graph. The graph is always negative, right? It's always below the x-axis because we have some asymptotic behavior happening at y equals 0. So as I take the biscuits out of the oven, they're going to continuously cool down to room temperature. They're always going to be cooling from that 100 degrees Celsius that it was when I took it out of the oven. So since it's cooling, this is the derivative. The temperature is decreasing, which means the derivative has to always be negative. All right, and finally, we want to know, okay, at time t equals 10, what is the temperature of the biscuits? Not the rate that is changing, because we're given a rate, so we want to go up to the temperature, which means we're going to have to use an integral. So what I'm thinking here is I'm going to go and make a definite integral from 0 to 10. Obviously, I need a 10 in here because I want it to, we want to figure out what it is at t equals 10 minutes. But the reason why I'm using 0 is because we're given that initial value in the problem where it says, all right, we know it's 100 degrees Celsius. So as I write this out, I'm just going to write b prime of t because in my calculator in a second, I'm just going to put in the full equation. dt, and that's going to be equal to b of 10 minus b of 0. So what ends up happening is I know that the temperature at 0, the biscuits at t equals 0 is going to be minus 100. We want to figure out what it is at b of 10. So let's find this definite integral. And the value that I get is negative 65.817. So negative 65.817. So all I need to do to this is add in 100 to both sides, and I'm going to get that b of 10 is going to be equal to 34.183. And then the units in this case is going to be degrees Celsius. So that's going to conclude this video. We do have one more video remaining with another contextual problem, and then you do have homework with more practice problems. So you're getting now into the meat of calculus as you're working with derivatives and integrals on a very consistent basis, and you're applying them to the world around you. Of course, if you do need help with this problem at all, please, you know you can reach out to me. I'm Mr. Hernandez, and this was Mr. Hernandez Teaches.